Good morning, students. It's already we have been meeting in the school. Now, as it was decided that our class is going on online only. So from today onwards, I'm going to have I will take a new topic that will be rational number. Rational numbers. You might be remembering the number line. The numbers can be represented on number lines. And there are types of numbers. We might have seen, you might have seen 1, 2, 3, 5 upon 6, 8 upon 7, minus 3 upon 4, square root 2, like that. 1, 2, 2, 2 upon 3, like that. You might have seen a lot of numbers, isn't it? So the numbers are of having many types. Now let us discuss. And we'll know about types of numbers. The first one is natural numbers. Natural numbers. Generally, whenever we say counting numbers, what we do? So 1, 2, 3, 4. We start counting from 1, isn't it? Means they are naturally coming. Naturally, whenever we say count numbers, what we do? Generally, we count from 1, isn't it? It means all positive numbers starting from 1. All positive numbers starting from 1. So, and such numbers are called natural numbers. For example, if you put a line here, now it is this 1, this is 2, this is 3, 4, like that, 5. It will go on like this. So unlimited number of there are unlimited numbers are there, and such numbers are called natural numbers. Such numbers are called natural numbers. Means numbers which starts from 1, 2, 3, like that. Such numbers are known as natural numbers. Okay, the next one now, whole numbers. Now, the simple difference between a natural number and a whole number is whole numbers also include natural numbers. Whole numbers includes natural numbers, but there is a slight difference that it contains one more number, that is 0. Numbers which starts from 0, 0, 1, 2, like that, such numbers are known as whole numbers. For example, if you draw a line here, this is 0 here, 1, 2, 3, 4, 5. All positive natural numbers, including 0, are known as whole numbers. All positive natural numbers all positive natural numbers including 0 are known as whole numbers. Now I think you understood the definition of natural numbers and the definition of whole numbers. Now the next one is integers. I think you might have heard the word integers. Now the third one is integers. So what are integers? All the numbers, all the positive and negative numbers, all the positive and negative numbers, including zero, are known as what? Integers. For example, if you can show them on the number line, so this is 0, and this is 1, 2, 3, 4, 5, like that. In the same way, from 0 to left side, there will be negative numbers, -1, -2, -3, -4, -5, like that. So such numbers are known as integers. All the positive and negative numbers, including 0. All the positive and negative numbers, including 0, are known as integers. So you can write all the positive and negative numbers. All the positive and negative numbers, including 0, are known as integers. Now I think you might have studied all these things in your previous class, but you might you need to remember all these things. So what are natural numbers, what are whole numbers, and what are integers? Now next, the fourth type of number, that is this one, rational number. So you might be thinking, everywhere we are writing the same number, 1, 2, 3, like that, 0 on, but each numbers are defined separately, differently. Why? Because the quality, they have got separate identities, they have got separate values for those numbers. So such numbers are called. Now, for example, now we are talking about rational numbers. So what are rational numbers? Now, first of all, you might have seen, such numbers. This is 1 upon 2, 3 upon 4, -5 upon 6, -3 upon 4, 1 upon 5, -5. So you might have seen such numbers, isn't it? So what are these numbers? Generally, you might have studied in your previous class, such numbers are called fractions, isn't it? Such numbers are called fractions. The same fractions are known as rational numbers. The same fractions are known as rational numbers. So what is the definition of rational number? The numbers which can be represented in the form of P by Q. Means this is a fraction, 1 upon 2, 3 upon 4 minus 5 upon 6 minus 3 upon 4 minus 1 upon 5. Any number, if it is represented in the form of P upon Q, or you can say the fractions, then represented in the form of P upon Q, and where Q is not equal to 0, means the denominator should not be equal to 0. And where Q is not equal to 0 and P and Q are integers. P and Q are integers. The numbers which can be represented in the form of P upon Q, where Q is not equal to 0 and P and Q are integers. Such numbers are called rational numbers. See, the same numbers. So integer means what? Integer means all numbers having all positive and negative numbers. All positive and negative numbers that can be represented in the form of P upon Q. Means some number should be in the numerator and some number should be the denominator. Such numbers are known as what? Rational numbers. And you must remember, any number could be written in the form of rational number. Any number could be written in the form of rational number. Any number. For example, even if you write 0, 0 can be written in the form of rational number. That is 0 upon 1. If you write 2, so 2 can be written as 2 upon 1. Any number, so 5, so 5 upon 1. Minus 7, 7 upon 1. The only condition we have is the denominator should not be equal to 0. Only condition is that the denominator should not be equal to 0. Such numbers are known as rational numbers. Such numbers are known as rational numbers. I think you understood what do we mean by rational numbers. Very important thing now. Now, so I will rub now. Now let us study the properties of rational number. Properties of rational number. So one by one we'll study about the properties of rational number. The first one. So first we'll study about properties of rational number. Okay. So what are there are three types of properties are there. The first one is closure property. Closure property. So what is this closure property? What is this closure property? Now, means in this closure property, what we are doing? If you add, see, if you want to study any property in mathematics, so there are four operations are there in mathematics. There are four operations are there in mathematics. What are those four operations? One is addition, the second one subtraction, the third one is multiplication, and the fourth one is division. So any numbers, if you want to check the property, they have to undergo with these four operations. Now let us study one by one. So what does that closure property means? Let us see. For example, now first we study about addition. Addition property. So we are studying about always remember, whenever we are doing something, we have to remember that what we are studying about. Now here what we are studying about, we are studying about rational numbers. And when we are talking about addition, means addition of rational number. Addition of rational number. Now let us check it. You can take any rational number. So 1 upon 3 plus 2 upon 5. So these are the two rational numbers. These are the two rational numbers. Now what we are studying about? Addition. Now they are rational numbers. We are studying about rational number and in that addition. Now here there are two rational numbers and we what is the operation here? As addition is the operation. So if we add two rational number, what will be the answer? Now, so here 3 5s are 15 is the LCM. Now 3 5s are here and 5 3s are here. 1 5s are 5 plus 2 3s are 6. So 11 upon 15. Can anybody tell me what is this 11 upon 15? Again, this 11 upon 15 is a rational number. 11 upon 15 is a rational number. 11 upon 15 is a rational number. It means if you add two rational numbers, the result will be again a rational number. If you add any two rational numbers, the result will be again a rational number. So now the second property, second operation, that is what? Subtraction. Subtraction. Again, we can take any two numbers, any two rational numbers, and let us check if we subtract one number from the another. So what will be the answer? For example, take any number. 2 upon 5 minus 6 upon 8, 6 upon 7. Now we have taken two numbers, that is rational numbers, that is 2 upon 5 minus 6 upon 7. So what will be the LCM here? So LCM is 5 7s are 35, 5 7 is here, so 7 5 is here. 2 7s are 14 minus 6 5s are 30. 14 minus 30 is minus 16 upon 35. So what is this minus 16 upon 35? Again, it is a rational number. Means if you subtract one from another rational number, then the result will be always again a rational number. The result will be again a rational number. Now, we'll do the third one now. That is what? Multiplication. Now, again we can take any two numbers. For example, we'll say 5 upon 6 into minus 3 upon 11. Minus 3 upon 11. Multiplication. You can multiply. Here it is plus, nothing means plus. Plus into minus. So minus will be there. 5 3s are 15. 6 11s are 66. So what is this number? Minus 15 upon 66. Again, it is a rational number. Means, if you add two rational numbers, you get a rational number. If you subtract two rational number, and again you get what? A rational number. And if you multiply two rational numbers, what you get? Again a rational number. Now the last operation, that is division. Last operation is division. Now let us check what happens when we divide. When we divide one by another rational number. So what happens? Division. For example, minus 1 upon 8 divided by 0 upon 5. 0 upon 5. Now minus 1 upon 8 is a rational number, and 0 upon 5 is also a rational number, isn't it? So now let us try to divide these numbers. So first of all, minus 1 upon 8, write as it is. Now in place of multiplication, division, make it multiplication. It becomes 5 upon 0. 5 upon 0. Now what is the answer here? Minus 1 into 5 is minus 5. And 8 into 0 is 0. So now, can anybody tell me, is it minus 5 upon 0 is a rational number or not? What is the definition of the rational number? The numbers, if they are in the form of P upon Q, and Q should not be equal to 0, the denominator should not be equal to 0, then such number is known as rational number. But here, the denominator is a 0. The denominator is a 0. It means it is not a rational number. It is not a rational number. So what it says? It means, you can write here, minus 5 upon 0 is not a rational number. Is not a rational number. Because, why? Because Q is equal to 0 here. Because Q is equal to 0 here. Therefore, it is not a rational number. Therefore, in closure property, you have to write here, in closure property, in respect of division, in closure property, in respect of division, in respect of division, closure property does not hold. Now, in respect of, so yeah, you are right. In respect of division, closure property does not hold. Hold means satisfies. Hold means does not satisfy. I think you understood. So what is the meaning of this closure property? Okay, now we'll move to the next property, that is, so you need to remember the properties very much. So the next property is commutative property. Next property is, that is second property, that is B, commutative property. Okay, now. So again, in this commutative property, we have to undergo with the 4 operations, that is addition, subtraction, multiplication and division. What is the first one now? As we all know. So what is this commutative property? Means, so LHS is equal to RHS. See, if you add or subtract or multiply or divide 2 numbers from one side, and that should be equal to the same numbers in the right hand side. Okay, then such means if you have to just a plus b is equal to b plus a. It means if you interchange the numbers, the result should be same. It may be at the left hand side, it may be at the right hand side. Now let us check. First you have to write here commutative properties. This should be like this: a plus b is equal to b plus a. Means if you interchange the numbers, the result should not affect. Now, as we are discussing about rational number, now first of all we start with addition. Now let us check it how addition is done. Now for example, 1 upon 2 plus 5 upon 6 is equal to, it should be 5 upon 6 plus 1 upon 2. Now you might have seen here, here 1 upon 2 is the first number and 5 upon 6 is the second number. And what we did here, so now we have taken first number as 5 upon 6 and the second number as 1 upon 2, and the sign will be where it was earlier. We should not change the sign. The sign should be at the same place. Now, so let us calculate the value of this, and after that we have to calculate this. If both are equal, the result is both are same, then it means the addition property holds. So now let us see. So 2 and 6, what is the LCM of 2 and 6? You might be knowing how to calculate LCM. 2 1s are 2 3s are, so 3 1s are 3. Now 2 3s are 6. So 6 is the LCM here, right? 6 here. Now 2 3s are here, 6 1s are here. 1 3s are 3 plus 5 1s are 5. Here also. Now what is LCM here? Again it is 6. 6 1s are 2 3s are, 5 1s are 5, 1 3s are 3. 3 plus 5, 8. 8 upon 6 equal to 5 plus 3, 8 upon 6. This means LHS is equal to RHS. LHS equal to RHS. It means if LHS equal to RHS, it means what? It means in respect of addition, commutative property holds. Means the commutative property satisfies in respect of addition. Now, I think you understood. So what do we mean by this commutative property? Now we are going to do with the next one, that is subtraction. Okay, now write down the multiplication now. Okay. Let us do multiplication now. Sorry, subtraction. Same thing. You can take any two rational numbers. For example, we'll take 3 upon 4 minus 5 upon 7 is equal to 5 upon 7 minus 3 upon 4. Now let us check it. If they are equal, it means, LHS equal to RHS, it means subtraction holds. Let us check it now. So what is the LCM here again? 4 7 28, 4 7s are 7 4s are, 3 7s are 21, minus sign as it is, 5 4s are 20. Again LCM is 28 here, 7 4s are 4 7s are, 5 4s are 20, minus 3 7s are 21. So 21 minus 20 is 1 upon 28. That is equal to 20 minus 21 is minus 21 upon 28. Can you say 1 upon 28 is equal to minus 1 upon 28? No. They are not equal. They are not equal. So in respect of subtraction, commutative property does not satisfy. In respect of subtraction, the commutative property does not hold. So you have to say LHS is not equal to RHS. So here you have to write in respect of subtraction, commutative property commutative property does not hold. Does not hold means does not satisfy. Does not satisfy. Okay. Now we'll move to the next, that is third operation, that is multiplication. The third operation will be multiplication. What is that? Multiplication. Let us check. Minus 3 upon 7 into minus 4 upon 9. So now if you interchange, that is minus 4 upon 9 into minus 3 upon 7. Let us check it now. Minus into minus become plus. 3 4s are 12. 7 9s are 56. Minus into minus plus 4 3s are 12. 9 7s are 66. Sorry. 7 9s are 63. It is 63. So you could see here LHS equal to RHS. You could see here LHS equal to RHS. It means it satisfies. It satisfies in respect of multiplication. Okay. Now the last one now, that is division. The last one is division. This is the fourth property, that is the fourth operation, that is division. Now, let us take any number. Minus 2 upon 5 divided by 4 upon 3. So that is equal to 4 upon 3. So minus 2 upon 5. Now let us check it now. So minus 2 upon 5 as it is. In place of division, make it multiplication. So it become what? The numerator becomes the denominator and the denominator become numerator. In the same way, here it is also 4 upon 3 into now 5 upon 2. 5 upon 2. 5 upon minus 2. So okay, now multiply. 2 3s are 6. 5 4s are 20. 4 5s are 20. 3 2s are 6. So now you can see here 6 upon 20 is not equal to minus 26. So 6 upon 20 cannot be equal to 20 upon 6. So therefore LHS is not equal to RHS. So again you have to write in respect of division, commutative property commutative property does not hold. Does not hold. So this is all about the second property, that is commutative property. So in the first closure property, what we saw we saw only the division does not satisfy, whereas in commutative property there are two things. One is the subtraction, and the last one, the division, does not satisfy the commutative property. So the next property will be discussed in the next class. So note it down, all these things, and we'll discuss the remaining property in the next class. Thank you.